So the focus of this video is how do I take an equation that's in general form and write it in vertex form. And to do this, we're going to use a process called completing the square. So a few things before we get started. We look at it, when we look at vertex form, we have here a perfect binomial squared. And that's going to be our goal. We want to make that perfect square, which is why we say completing the square. So if we think back to our Punnett square, which help us visualize the idea of this square, we got x and a minus h, and we have x and a minus h. So this is x squared. That's our quadratic term. Here's our h squared, which is our constant term. And then down these two, we have our negative h, xh, negative xh. That's our linear. The idea we're going to do is say, I know what my quadratic is. I can figure out what x is. I know what my linear is. I can use that to figure out what my h's have to do. And then I'm going to add something to make the square. So that's why we're going to call it complete the square, because we have to say, what do I add right here? But you say, I can't add anything to the equation. That's going to change it. So the other thing we're going to use is what we're really going to do is we're going to add 0. Because adding 0 will not change the equation. Well, 0 I can write as my h squared minus h squared. So I can add my h squared to complete the square. As long as I take it away again, then I'm really only adding 0. But that taking away can happen outside the square. Kind of a little weird, but we'll see it in action. Hopefully that'll make some more sense. So let's look at some examples. In this case, I got x squared plus 20x minus 5. When I'm working with this completing the square, I'm trying to build my Punnett square, I'm going to just focus on my quadratic and my linear term. I'm going to ignore everything else for right now. So I'm going to build up my square because I know x squared has to go into this place, this first corner. So I have to have x and x, which works. I want x minus something. My linear term here has to be split between these two squares, so I'm going to take that and divide it by 2. Because if I divide it by 2, I got 10x there, I have 10x there. 10x plus 10x is 20x, which is what I need. But I look at the sides, I have x plus 10, I have x plus 10. For it to be a perfect square, I need the same thing on both sides. So that's why I divide it in half, split it in half. Now, what do I need to complete the square? This is 10 and 10. I need 100 right here. So this is what I have to add to complete the square. So I take my equation, which is y equals x squared plus 20x, and I have my minus 5 over here. I add my 100 to make that my perfect square. But since I added 100, I also have to subtract 100 because I'm really adding 0. I can't change it. But this 100 is outside, so that's okay. Because this x squared minus 20x plus 100 is my perfect square, is my x plus 10 squared. And then outside the square, I have my minus 105. That's my k value, my vertical shift. So that's my equation in vertex form. And that's that process of completing the square. Let's look at what kind of things can be thrown at us to make this a little more difficult. In this problem, x squared plus 3x plus 20, again, I'm going to ignore the 20 to start off with. Just look at that x squared plus 3x. The thing that's not nice about that, I got x squared here, x and x, I'm happy. But I look at this 3x is not even. Well, so it's not even. I can still divide it by 2. I got 1.5x. I got 1.5x. So this is x plus 1.5, x plus 1.5. So what I have to add here is 1.5 squared. 2.25. That's what I got to add. Got to work with some decimals? That's okay. We can work with decimals. We got x squared plus 3x. And my plus 20 I'm going to stick off to the side. I'm adding my 2.25 to complete my square. And then I'm taking it away because I can't add anything to this. I got to keep it the same. So I get my x squared. Sorry, I don't get x squared. I got my x plus 1.5 squared plus 17.75. Again, I didn't mention it on the last one, but I'll mention it here. My a value, I don't have one. My a value here is 1. My a value here is 1. If I have a different a value in the two forms, there's something wrong. These aren't bad as long as I have an a value of 1. So we'll look at an example when a is not 1. When we look at this one, we have an a value that's not 1. So if I make my Punnett square, it's not as easy to fill up this with 3x squared. Do I really want the square root of 3 times x? And then what do I do from there? It complicates things. I would rather not have the 3 there. So we get rid of it. How can we get rid of it? By factoring. I'm going to take this and factor out the 3 from the x squared. I'm going to factor out the 3 from the 18x, making that 6x. 3 doesn't go into 7, but I'm ignoring 7 for now, so I'm just going to stick that on the end. I don't have to worry about factoring that out from the 3 because I'm just looking at the 3x squared minus 18x. So I'm factoring it out from there. That will save us a little headache in the long run. So then I can put my x squared here. I can take my negative 6 divided by 2 is negative 3x. So I got minus 3x minus 3x. That 7's in my way. Let's move that. Oh boy, that doesn't like that. Try this again. Okay, we'll take a little bit of that with us. That's okay. So we're going to have x minus 3, x minus 3. That's going to put us a 9 here. So 9's what we have to add to complete the square. So we have 3x squared minus 6x. We got our plus 7. Now, I add the 9 in here. I'm not really adding 9 to the equation because 9 is inside the parentheses. It's being multiplied by 3. So when I have to take it away, I also have to multiply it by 3. That's the tricky spot, what messes you up the most. But we're going to get this as x. Now since this was minus, it's going to be minus 3 squared. 9 times 3 is 27, so we have a minus 27 plus 7, so we're going to get minus 20. And our final answer is 3 times x minus 3 squared minus 20. Again, started off with 3x squared, ended up with 3 times the quantity squared. We need that. That has to work. The big thing, we're doing this complete the square. Focus it down, simplify the expression so you can get to that x squared plus or minus something times x. Then you can do this idea, completing the square. But whatever you add to make the square work, you have to subtract. If you add a multiple here, we got to add that multiple there. That's completing the square.